Okay, so this is a very quick video about TCP, which stands for Transmission Control Protocol. It's a protocol that operates on layer 4, the transport layer of the OSI model, which is basically about how computers communicate with each other over the network and how data is transmitted over the network. So when deciding, so on the kind of OSI model, when deciding which transport protocol to use in order to transmit the data from either client to server or just over the network in general, there needs to be a decision made about the protocol that is used to transmit this data. So the main two protocols used on the transport layer are either TCP or UDP. UDP, user datagram protocol, is used more for, say, streaming, where packets can be lost, packets can be lost, and basically it's very unreliable. It's connectionless. So that wouldn't be used if data needs to be definitely received. Data needs to be received in a particular order, and any lost data can be retransmitted. And so, like, for example, if you're streaming and it's a bit glitchy, you lose a second here, you lose a second here, it's absolutely fine. It doesn't affect the user experience. However, if you are a web browser looking for a transport protocol to use to transmit the data across the network, then you probably wouldn't want to use UDP because it's unreliable. You probably want to go for TCP, Transmission Control Protocol, because it's reliable. All the packets will be received in the correct order, and any packets lost can be retransmitted. So that's TCP. The reason why, say, some clients of the network may not want to use TCP, might want to prefer to use UDP if they can, is because of the latency that is increased through the use of TCP because of the three-way handshake. So at the beginning of a TCP connection, before any data is submitted between the computers, an end-to-end connection needs to be established. And in order to establish that end-to-end connection, there needs to be something called the three-way handshake, which I think creates 3 extra round trips. Correct me if I'm wrong, but I think it creates 3 extra round trips between client and server before a connection is established, and therefore before any data can be exchanged between the two computers. So this is a very simplistic version of the TCP three-way handshake, but this is basically the basis of it. So the client, for example, a web browser, wants, for example, Google, the HTML for Google. So, which is the first, the HTML is the first file that's requested from a web browser to, for example, a server for a web page. So the client will say this is my computer in London, and say this is a server that exists somewhere in the US where, well, hopefully not in the US, hopefully they have a CDN, so it's closer. But say this is a server somewhere in Europe where the data that I need exists. So I want to communicate with the server. Well, my web browser wants to communicate with the server. However, because it's a web browser, because it's web pages, they will be using TCP, not UDP. Therefore, they'll run into the need to create a three-way handshake before any data is transmitted between the two devices. The first stage of the three-way handshake is the client sending a packet to the server, which basically is the client wanting to synchronize with the server. The server will then receive that package and will send its own package, which both contains an acknowledgement of the client's desire to synchronize and also its desire to synchronize with the client. The client receives that package, and then the client sends a third and final packet to the server, which basically acknowledges the acknowledgement of the server acknowledging the synchronization, its synchronization in the first place. And so therefore the once this acknowledgement of the acknowledgement has been sent, the three-way connection is established. There's a bit more to this. For example, they kind of send a secret code, which is incremented on the two final parts of the three-way handshake, I believe. But I'm just trying to keep it very simple so I understand an overview of it and how it works. So once the three-way handshake is complete, the connection is established, and TCP allows both devices to speak freely to each other whenever they want. However, for example, when using HTTP on top of TCP, it won't be both devices can freely speak to each other whenever they want for however they want. In terms of the way that HTTP is designed, if the desire um, for for the ability to speak whenever you want, however you want, is desired, then you'll have to kind of add to the HTTP. I think yeah, using WebSockets, which I'll get into in a different video. Um, but yeah, so basically that's TCP. It's just a three-way handshake um, that the client and server need to do together in order for basically data to be sent between a client, for example, a web browser, and a server if TCP is being used on the transport layer. So I'll leave it there. I think that about covers it. And I'll make some more videos about um, HTTP, just really going into it, just so I can fully understand it, because I'm still a little bit hazy about a few things. So I hope this helps someone. It's definitely helped me to describe how I, you know, how I understand how everything works. And yeah,